Greetings. Today we'll discuss about DT-DC interface. One among the DT-DC interface is the EIA232 interface. EIA is nothing but Electronic Industries Association 232. There are four basic functional units involved in the communication of data: a DT and DC on the one end, and a DC and DT on the other end. The DT generates the data and processes them along with necessary control characteristics of the DC, and the DC converts the signal into appropriate format to be transmitted through the transmission medium and introduced onto the network link. At the receiving end, this process is reversed. A DT can be generally anything like a microcomputer, printer, fax, or anything. And a DC is something but a very good example for DC is a modem. So, this presentation tries to explain the interface between the DT and DC. This interface standard is defined as EIA232, and it has three specifications: electrical, mechanical, and functional specifications. Now we'll discuss one by one. First, we'll see the mechanical specification, then electrical, and finally we'll discuss the functional specification of the EIA232. So here, this interface try to define the mechanical, electrical, and functional characteristics of the connection between the DT and DC. So this gives a clear picture of the electrical specification, how the data can be recognized. So the data can be transmitted in the form of voltage in the transmission medium. So any voltage that falls between +3 to +15 and -3 -15 can be recognized as the data, and +3 to +15 will be considered as 0, and -3 to -15 will be considered as a negative voltage will be considered as a 1. So this is the electrical specification, and it also contains control characteristics. Any voltage that exists beyond 3 and that's below -3 can be considered as the signal or a thing for the control information. So this is a mechanical specification. This one example of EIA232, it contains 25 pins. This is called as DB25 pin connector. The pins are arranged like this. The one end the pins will be there, and the other end there will be a receptacle for tubes. The pins will be arranged like this: 13 on top and 12 on the bottom. Each pin will be connected to a wire, and this wire will be in turn connected to a receptacle or cuboid. The pins are called as male connector, and the tubes or cuboid at the other end are called as female connector. The data passes along these pins to the receptacle. This is all about the mechanical specification. We'll discuss about the pins. So the pin number 2 is used to transmit the data, and 3 is used to receive the data, and the 14 and 16 are used for secondary transmit data and secondary receive data respectively. So these are the other pins which are used for control and timing signals. And the pin number 4 is used to request to send the data, and 5 is to clear to send the data, and 6 implies that DC is ready for transmission, and 8 implies that it has directed a signal line detector. Likewise, the other pins are used for the electrical specification. This is a timing pin. 15 and 17 are used for the timing, transmitter signal element timing and receiver signal element timing, and 24 pin represents the transmitter signal element timing. These are the other pins which have minimum use. So now we'll move to the functional specification of the DT-DC. The data transmitted in synchronous full duplex transmission, it includes 5 steps. Step 1 is for preparation of the interfaces for transmission. The 2 pins 1 and 7, the shield and ground are active between both the sending and computer or modem, and the receiving computer or modem. Step 2 ensures that all the 4 devices are ready for transmission. The pin number 20 and 6 implies that all the 4 devices are ready for transmission. First, the sending DT activates pin 20 and sends the DT ready message to its DCE. The DCE answers by activating pin 6, and returning a DCE ready message. The same sequence is performed by the remote computer and modem. The next step is physical connection between the sending and receiving modem. This is a third step. This is a third step. It's the first step that involves a network. First, the sending DTE activates pin 4 and sends this DTE a request to send the message. The DCE transmits the carrier frequency to the idle receiving modem. When the receiving modem detects a carrier signal, it activates pin 8, the received signal line detector, telling its computer that the transmission is about to begin. After transmitting the carrier signal, the sending DCE activates pin 5, sending its DTE a clear to send message. The remote computer modem performs the same step. Step 4 is the data transfer. Step 4 is used to transfer the data. The initiating computer transfers data stream to its modem over circuit 2. This is pin number 2. Here data is transmitted. The initiating computer transfers data stream to its modem over circuit 2, accompanied by the timing pulse over 24. 2 and 24 is used to transfer the data, and data in pin number 2 and 24 carries the timing signal. The modem converts the digital signal to an analog signal and sends it out over the network. The responding modem retrieves the signal, converts it back into digital, and passes the data along to its computer via circuit 3. It receives the data through the circuit 3, accompanied by the timing pulse at pin number 17. Likewise, the responding computer follows the same procedure in sending data to the initializing computer. In this way, the data is transferring from the sending DTE to the receiving DTE. Pin number 2 and 24 are used to transmit the data and timing pulse. In the same way, 3 is used to receive the data, and pin number 17 is used to receive the timing pulse. So, we know that already we have established the carrier signal using pin number 4, 5 and 8. Once the transmission is completed, we can clear off all the carrier frequency. 4, 5, everything is clear, including 8 is clear, and now the data is transmitted completely. So this is one example how data cannot be transmitted without a DC. So pin number is used to transmit the data and 3 to receive the data. So this is the DT and this is the DCE. So here the data is transmitted and here the data is received. So with the help of a DCE. So in case of a transmission without DCE, we cannot transmit the data. Here a collision occurs. So there is one more concept, null modem, where we can transfer the data between two DTs without the help of a DC. Thank you. This is all about DT-DC interface.